Good morning and welcome to the CADclass podcast. I'm Josh.
I'm Jake.
Hello, Jake. Where are you? Nice little
Can you hear
delay. Yeah, I can. Just teasing you.
Oh my god.
We always have audio issues, so now I just get to mess with you.
Oh,
Good
God.
morning,
Oh, that's good. That's good.
Grandpa Makes. Yeah.
Good morning, everyone.
Makes. It is nice to have you. Good morning, printed by John. Nice to be here. This is week 2 in a row after our long
I know.
streak
Can you believe it?
of how many pods we're back.
Oh
in,
my
back in
God.
business.
So many. It does feel good to get back into the rhythm of it, though.
Sure does.
Does.
The community feels like a little bit more time together when we pop on here and say hello and show off what you make. And so I noticed a significant drop off in the I made of things and like the sharing of what happened on YouTube. On Discord, and I was like, I wonder what's causing it. I realized I think it was us not being here that caused it. So, Jake, speaking of Discord, we are just about to hit 1,500 members on Discord.
I know. It's so funky.
That's wild. And we just started this on a whim. I didn't even know. I had never actually used Discord when we started.
No, me either.
And you hadn't either. And I thought maybe we just see what happens.
And it turned into like the best community ever.
And it turned into this awesomeness. So
awesome.
Thank you all.
Thank you ever so much. Everyone that's contributed to the Discord and made everything that we've ever produced even better. Just hats off to you. Thank you ever so much. You guys are the lifeblood. You keep us rocking. All right, guys. So today on this pod, we're going to be talking a little bit of news, a little bit of actionability with selling your 3D prints. Which is a topic we haven't touched on. Weirdly enough, how do you actually sell your 3D prints? Talking a little bit about my problem with 3D printing, with build plays, and why it's been such a nightmare for the past week. And then finally, some more things that you can do with text commands and combining AI with CAD software in a way that's actually useful and not as more of a pain in the ass as every other AI CAD software is. But I think I want to get started by chatting about public domain. So for anyone that doesn't know, public domain is effectively the action that any creative works made by humans after X amount of years goes into the public. It's essentially owned by no one, and you can use it creatively and liberally. And you don't have to pay any money to the people who actually created it. But it's only after, I think it's 100 odd years. But it's effectively the reason that cultures can share creative arts where, Hansel and Gretel and Pinocchio and all of these kind of classic stories can be shared and transformed throughout the years. And it is a positive thing. And it used to be a relatively short amount of time. And then Disney being Disney, they just had lawsuit over lawsuit and just pushed it for more and more and more years over the time. Ironically, even though every single one of their original movies was a public domain thing. But regardless, we are now getting more and more things every single year that comes into the public domain. Very famously, Winnie the Pooh came into the public domain a couple of years ago. Steamboat Willie, not Mickey Mouse, Steamboat Willie, came into the public domain last year. And with that comes a slew of crappy horror movies every single time. I don't know if you know this, Josh, but there is always like, oh my God, let's make Winnie the Pooh into a killer monster. And oh my God, we need to make Steamboat Willie into like this terribly crappy, not actually any good horror movie. It happens every single time. So you can see the calendar of like characters that are going to be coming into the public domain in the future. So like all the original Disney characters are going to be coming into the public domain eventually. Superman is coming around the corner. Popeye is coming around the corner. So all these things, they will just become available to use. But the reason that we're talking about it is that there is now a kind of a new entry from our side of the world. 3D Benchy is now officially part of the public domain, which is really, really funky. A lot of people have been surprised because they didn't realize it wasn't already free to use. And it's completely not. It has always been effectively behind a company's ownership. within the world of 3D printing and CAD modeling, 3D modeling, it has always come with this exuding force of being available and free to everyone, except for a couple minor things. Like if you spent hours and hours working on a model, it's kind of accepted. Like, yeah, you can charge a couple bucks for the STLs. That's kind of, we get it. It's okay. But with Benchy, it's now available to use by anyone, being able to be changed and manipulated. Previously, all of those changes, all those edits and tweaks that we've all seen for close to a decade now, apparently they've all been illegal. So
Yeah,
now,
I'm reading it right here. So it's under Creative Commons Attribution, no derivatives 4.0. So you can use it, you can download it, you can use it, you can give it away, whatever, but you can't modify it. Oh, it
really,
says no, that's not true. That's not true. No, now that it's in public domain, I believe you can
you're
do
now
whatever you
able
want
to
with it.
you can do whatever you
But
want.
no, that's not true. You can modify it for personal use under the old license, but you couldn't
Oh,
modify it for professional use.
bizarre.
There we go.
But I think this is genuinely one of the first instances of like 3D printing community like previously behind effectively a business's paywall, now being released to the public. This is kind of the first one that I can think of ever, but it's just totally bizarre, right? Like I can't think of any other example of this happening. So it is joining the ranks of Winnie the Pooh, Steamboat Willie, and now 3D Benchy. Lovely. The other thing that I wanted to talk about today, which is a topic that we have never ever touched on, really strangely, but this is a topic that literally since last night we have been approached to do. So, and that is how to actually price your 3D prints that you are going to be selling. So, Josh, do you want to give everyone a very brief history of CADclass in the early days and how we used to be a 3D printing farm company?
Yeah, I'm happy to do that. So once upon a time, Jake and I had the lightning rod moment. I think this is the proper way to contextualize it. Where we were working in a workshop, and some of you may have heard this story before. We've told the story a couple times, but maybe I'll go a little bit deeper into it because I think it's actually relevant. It's actually extremely relevant for people that are newer to the hobby or are trying to transition this into a business. So we were working at a workshop. We were working with one of the most common table saws in the world called the DeWalt DW745, I think it is, and a dust collection system. And we didn't have the dust collection adapter to fit these two things together. So I'm working with lots of kids every day and just basically having to either tape this thing together, super annoying, or
Literally
not use the dust collection adapter at all and just spew dust literally all over me. I mean, there'd be dust in my shoes, dust everywhere. And so I went online, as any reasonable human being does, in this would have been what, 2019 or so, 2020.
Oh,
and I went online. I went online and
Oh
I thought, okay, I'll just buy the dust collection adapter. I measured it with some calipers. I plugged it into the back of the machine and didn't fit. It was just wiggly. It was loose. So I had taken the correct measurements in both metric and imperial and fractions and in decimals and searched for the correct adapter, bought it, arrived, didn't fit. I'm like, oh, that's annoying. Maybe I made a mistake. Went out, measured it again, did another internet search for adapters to fit these two pieces of equipment, including all the measurements I had, ordered another adapter, that failed. Third time, I made the cardinal sin of adapters, and I bought a quote-unquote universal adapter, which is completely ridiculous. If you're buying something universal, it's almost certainly not going to work. So I bought this universal adapter, same deal. It arrived. No, by the way, I've been researching this for a couple of days, and that's a lot of time to try to find an adapter. So I got this universal adapter, of course, didn't fit. In any way, in any iteration that I tried. I'm like, this is completely ridiculous. And that's when it hit me, wait a second, we have a 3D printer. Why don't we just use our 3D printer to make one? That would have been far easier than purchasing one of these things and going through this whole, we have calipers, we'll measure it, we'll just make the perfect one. So Jake, I approached you and I said, hey, can you just design me a little adapter to fit the dust collection system to the table saw? And you're like, yeah, absolutely. Happy to do that. And that's what he did. He printed me one. I plugged into the back of the table saw and it fit absolutely perfectly. And that's when I realized, okay, if I'm having trouble finding this adapter for this table saw, other people must be having this problem as well. So this was about 20 cents in plastic. It was a 10-minute design. and it was about a 2-hour print. So I thought, oh, why don't I just put one of these things up for sale on eBay? And the insight was that the problem was, I'm sure somebody makes an adapter that fits these things somewhere. But the problem, as I saw it, was that you couldn't actually search for it. So the searchability online was bad. So I thought, okay, well, I'll put the model names of both the table saw and the dust collection system. I'll put the sizes in metric and imperial. I'll put it in decimals and fractions. And I'll write a nice description saying, hey, this solved my problem. Maybe it'll solve yours. I'll put it up for sale on eBay and see what happens. And Jake, do you know what happened?
We sold on the first day.
The first day that we put it up, we sold one. We're like, that is super interesting. We were selling them for $20, and this was about 20 cents in plastic. And like I said, a couple hours of work. And so that was just instant, like, hang on a minute. This 3D printer is not a toy. I mean, it can make toys, but this thing is a tool, and it solves real problems. And that's when we thought, oh, well, let's just keep pushing the boundaries here. And so then we transitioned to trying to make adapters for other table saws and for other dust collection systems. And it turns out there was absolutely no market.
Not one of them sold. Not one
of the other adapters sold. It's like there's no market for these other adapters, but this specific adapter sold really well. So that's when you and I were like, wow, we could turn this into a business. These 3D printers are not expensive. We could fill our entire garage with 50 printers. And if these things were, if 50% of the time, 50% of these printers were working and making stuff, and it was like $2 to $3 an hour, we have ourselves $1 million a year business. And so you and I went down the rabbit hole of trying to create and start a 3D printing business. And that's where that was the original, when it was called Sliceform, that was the original idea behind Sliceform. We'll just make things that people need. We'll look for reproducible products that we can make specifically on 3D printers, and we'll go from there. And we did get some clients. So we did pick up a couple of clients here and there. That is true. But finding clients was really
pretty by John saying, I used to sell things on eBay, and my fastest sale was in 5 minutes.
Would love to know what it is.
That's
would love to know what it is.
Crazy. Yeah, let us know what that is, man.
Super fast. So we thought, okay, well, let's just transition this to scalable products that we can make on a 3D printer, and we'll go find them. Problem was, where the heck do you find these models, and what do you do about it? So we kind of experimented with a handful of different models. One of them was a tutoring model where you actually, I would advertise that we can come help you learn how to 3D print and make CAD models for your 3D printer. It will sort of work alongside of you. And then the other model that we tested was actual R&D product development, where we'd come in, we'd help people develop products, and we would kind of see what happened. And it kind of worked. What I'll say is that it worked well enough for us to get some seed funding to transition the idea to what eventually became CADclass, but not well enough that either one of us felt like we could do this full time and hope to make any real progress here. I think also the other side of it was that it's a 3D printer, and we're competing with more and more people on that market or in that market. It's not that hard to set up this factory. It's not that hard to build this business. What's the defensibility of this business? Can't people just come in and disrupt us basically every week? I think the answer to that is mainly yes, not always, because there's not all that many professionals, and it's still a lot of it's about customer relationship management and building these relationships. But that was the origin story of CADclass. We ended up also making a couple of other designs. One of them was a table saw jig that helped you make your segmented bowls. So you made a jig.
I used to do a lot of wood lathing. And it's like a super ridiculously hyper niche thing. But it was a design that I would do, that I iterated on over and over and over again, and just made, like, slowly but surely made it absolutely a perfect product. And it didn't sell like hotcakes.
It did sell. I think we probably
really
sold
weird.
a dozen of them.
No, we sold way more than that.
Did we sell more than that?
Oh, hell yeah. But it was literally like, it didn't take up that much space. So I just printed out effectively a bucket full, assembled it, didn't take too long, gave it to Josh, and he just had it in his office. And every single time we sold one, just print out a label packet and throw it into the outgoing mail. And it was so unbelievably easy. As far as like side gigs go, it was, good Lord, it was perfect.
So one of the things that came up, let me just set the scene here. So that was kind of that was the origin story, and now that sets the scene for what became one of the biggest questions that we get in our community of people that, especially people that have these 3D printers and they're trying to make and sell their own models. And that question is, how do you determine what to sell one of these models for. So, Jake, with that, take it away.
Really quick, double check you're on your show mic as well, Josh.
Oh, is it not on the Shure mic?
I don't know if it pops off or not. Anyway,
Mm.
while Josh is doing that, so one of the things that we ended up kind of discovering very quickly is, well, coming up with a price for a product is
I was definitely
hey,
sure, Mike. That sounds
there we go.
Bet 1,000,000,000 times better. All right, sorry about that. Yeah,
sorry about it. So effectively, when you're pricing out a product, very, very strangely, the actual price of the material and the advertising and all that stuff that goes into it is oftentimes not really the most important aspect. It is what is the value of this product, and what is the person willing to pay for it that determines the value of the product. Very, very simple economics. But it's shockingly much more of a gamble, much more of a fluid description that gets you to the price of a product rather than actual mathematics. And this is a completely different process to if you have a client that you have who says, hey, I need 100 of these things. How do you actually price it out for a one-off piece? It is significantly different. And coming to the price of it can literally be, if you say, it makes 3D printing. The material's really inexpensive. I don't know, I'll charge you $50. And then they go, great, awesome. And then they go, yeah, I put my file into a bunch of these websites and it said it was going to cost me $500. You go, well, they're usually a little expensive. And then you go online and plug in all of your values into like an online 3D printing price calculator. And it's like, oh, damn, I should have charged like $250 minimum. And so it's effectively one of those things that is completely calculatable. And it takes into account a bunch of things that people completely forget to do. And they oftentimes massively undercharge themselves. So last night we had one of our old buddies basically reach out to us and said, hey, I've got an order for my work. All of our 3D printers are down. Do you still have all of the capabilities to print out a small run of one-off parts? And it was like, yeah, dude. Like it's one of those things that's like, it's your buddy prices. I'll just charge you effectively the material. Like, don't worry about anything else. All good. But we wanted to go over all the processes if you were to actually charge this for a person. And all the parts that go into it effectively will just give you a minimum cost. You can charge anything above that, but it's going to be dependent on your time, your material, your printer, everything like that. So very, very quickly, most clients, they just want an initial quote. They just want to know, hey, roughly what should I be looking at? And this is when you take their file without doing any inspection whatsoever, chuck it into your slicer software. If they need 100 of them, put 10 in there. And you can effectively do a really quick example of like, okay, I'm roughly guessing this is going to cost this much time in print time, which is really important, and also this amount of weight in the grammage of the material. A lot of people, when they're coming into pricing, they go, oh God, I'm sure the electricity is going to be a huge chunk of the pie chart. No, not really. It's a tiny bit. It's, sometimes like 1% of the cost. It's pretty minor. But we'll go through a ton of the things. Most of the time, the cost is actually the man hours that goes into all of it. So that's usually a big thing. But very quickly, we just wanted to go through a super duper basic. This is like bare bones minimum what you should be charging for all of your materials, or all of your prices, I suppose. So really quick, all of your inputs, you basically effectively just need to know roughly what is the grammage of all of the material that you're going to be using on your piece, what is the print time, what is the cost of any consumables, and then what is the total time that you're estimating for the CAD work, which is usually the most amount of cost in this part. How much of the design do you need to tweak for this print? Basically never will your client give you an STL or an OBJ or any file and, oh, it's perfect. You don't need to change a single thing about it. It's like that never happens ever. So having in that CAD time, having in the slicing time as well is one of those things that people miss. the amount of time that people spend that they don't charge for is insane. So slicing time, prep time, and post time are all things that you need to take into account. Pulling down filament, loading it into there, purging it, cleaning it, prepping your build plate, making sure you've got all of your organizing, the plastic bags ready, the shipping labels, all those things. That's your time. So please do charge for it because everybody else does. All the post-processing, clearing off any brims, any skirts, any part of your build plates, any part of the print, removing supports, filing, cleaning off any burrs. These are all things that you completely forget about when you're charging. And then as soon as you go, oh my God, I need to print 100 of these things or 200 of these things. And you go, yeah, removing the supports of a part, that's not such a big thing. Times 100 is unreal. If I can give you guys any advice at all, lean into recommending to your client, hey, I'm going to need to pull this into my CAD software and I need to tweak some things about it. I need to change the angles or the overhang or all this stuff. Well, that way I don't need to use any support material or any brims or anything like that to basically print this. And it's going to save the client money. You're going to be charging for your time in the CAD modeling, but you're going to be saving material and post-processing time in magnitudes more. So even though they'll go, nah, just go, really double think, really check. Are you sure? Are you sure? Are you sure? It is always going to be better. Pretty much John said, I'm thinking about getting a butane torch to instantly get rid of stringing. You can totally do that, or you can get yourselves one of this, a super duper inexpensive. I got this from Harbor Freight for like $20. It's effectively just a heat gun. This is super duper inexpensive, and you can get rid of all of your little fuzzies and strings in exactly the same method. What I used to do to get rid of, as far as a post-processing en masse process, which I don't recommend, is I used to spray my entire build plate with 99% alcohol, light it on fire, and then immediately blow out the flames. And it would work awesomely. If you only let it set on fire for 1 second, it gets rid of all the stringing, and it also doesn't melt any of your parts, which is totally effective. It completely works. Do not do it. It is totally a fire hazard risk. Do not do it. You will burn yourself. I have burnt myself. Do not do it. Total side story. I did that. I printed out a little low poly skull vase that we do every once in a while for like some of our shows. And there's like some string inside. I think I did it on a material that was like a little bit, had some moisture in it. So there's some string in there. I'm like, big deal. Spritz some alcohol in there, lit it on fire, a little bit of flames, went in there to blow it out. All the young girls and boys, I'm sure they know exactly what happened. The flames went into my face. So the night before one of our events, half of my eyebrows were melted off. And it was effectively all of that, a bit of my mustache, a bit of my beard, and all curled up and melted away a little bit. Don't do this. I want to tell this story for a little while. Yeah, do not burn or melt your parts. You can use a butane torch if you'd like. Heat guns do exactly the same thing. But post-processing is the biggest part of this. Yeah. Do not set yourself on fire. I've set myself on fire way too many times when I've made stuff. I think I'm a little bit danger prone. Like I set myself on fire when I was trying to teach myself. Yeah, I set myself on fire when I tried to teach myself aluminum TIG welding as well. That was basically TIG weld, because you have to clean everything with acetone and alcohol. And it was started welding. And I'm like, I feel kind of hot. I took off my helmet and I splashed some acetone on myself that ignited, and my entire leather apron was on fire. Yeah. Don't do that. Anyway. So effectively, your input's going to be the grams of filament, the print time, any consumables, and then your time for CAD work, slicing, post-processing, and pre-processing. Those are the 4 things. As far as the costs for all the outputs, this is going to be made up of your filament, your electricity, your depreciation, and your man or woman hours. For the filament, that's pretty easy. Just one of these clients' work that I'm doing is going to be taking 312 grams of filament. We bought this roll of filament for $30. So you take the amount of grammage divided by 1,000 grams for 1 kilogram and multiply it by the amount of, or that $30 per kilogram. So for this client, it's going to cost $9 and some change for filament. Pretty small. The electricity, this is going to be based on 2 different factors. What is the cost of your electricity at your house or your office? And then what is the wattage pull for your printer? So this is a Bamboo P1S. This pulls 0.3 kilowatts while it prints. So that's basically the flow. It's kind of like the velocity of any or of all of your pull. Weirdly enough, although this is a much bigger 3D printer and it's got a lot more electronic fixings to all of my previous printers, this has the exact same wattage pull as an Ender 3.
That's crazy.
Is that not bizarre?
That's crazy. It doesn't even make sense.
It's super duper strange. So even though this is like way, way, way better than an Ender 3, I think we can all agree to that. The exact same electricity pull. So you effectively pull, or you multiply that 0.3 kilowatts multiplied by the amount of hours that you're 3D printing. For this job, it's going to take 19 hours of printing time. And you effectively multiply that by your kilowatt per hours. That's obviously going to be changed where you are in the world. It's also going to be fluctuating about the time of day and also the day of the year. In summer, electricity costs usually go up, especially in warmer climates because you need more air conditioning. So it totally fluctuates. But all in all, this is going to cost my client about $2 in electricity. It is super duper minor. And effectively, if you have a client that's wanting a rush job, a couple bucks on electricity is totally minor. But weirdly enough, the bigger thing is depreciation. This is a big thing that people always forget to add in onto their pricings. It's really simple. You effectively say, what is the total amount of hours that my job is going to be prints for? What is the lifespan of your 3D printer? And what is the total cost of your 3D printer? So I took this one. All right, it's a 3D printer with an AMS system on top. I have that cost of that printer. You can do some pretty quick research into how many hours this printer can run for before it's basically defunct. Most 3D printers, weirdly enough, apparently this is like a total standard. They usually run for about 3,000 to 5,000 hours before it's like substantial maintenance, to the point where you're like, yeah, I kind of need to either buy a new 3D printer or I need to do a lot of maintenance onto it. I need to replace some parts. I need to pay for those parts. I need to do some maintenance time on it. So about 3,000 to 5,000 hours putting into it is totally standard. Weirdly enough, it's the exact same value for an Ender 3 and for a Bamboo. So the total cost that goes into it is around $6 of depreciation for 19 hours. Again, if you have a really substantially expensive 3D printer, that's going to go way, way, way higher. If I'm running this on a Stratasys that costs 10, 20, 30 grand, that's going to be a totally different cost. So that's going to be fluctuating depending on what printer you have. But generally, again, pretty small. The man hours that goes into it is obviously going to be the largest aspect. So it's just going to be based on rough estimation. Oh, I think it'll take me about half an hour for the CAD. Oh, I think it'll take me about 10 minutes to do prep and post and all this kind of stuff. So totally keep it really rough. Tell your client all of this. This is a rough calculation. I will get you a final price. But obviously, in the estimation, you want to be a little bit more liberal on the hours, just so you don't say, yeah, this will cost maybe $20. And then you come back to them and go, yeah, $100, please. That's when the client's like, what the hell? So yeah, absolutely be a little bit more over the top with your estimations. And after all of that, you'll be pricing it up and you'll go, okay, this will cost me X amount of money because I've added up the filament, the electricity, the depreciation, and the man hours that goes into it. A lot of people will then go, yep, that's my cost. And it's totally not. You haven't even factored in fails, which is a really big thing that not a lot of people think about. The standard across every single 3D printing pricing job is always to tack on an additional 10% for fails. It's completely expected in any client buying system. If you say, yep, I'm reckoning if I'm doing 10 build plates and one of them fails, that's not uncommon. Obviously, if you've like dialed in all of your settings, that just gives you a little bit of wiggle room effectively. But adding on an additional 10% for fails is totally expected. Oh, my filament got a jam. Oh, I need to order a new one, get it shipped in. It's going to take some extra time. My build plate? Yeah, my build plate. Totally broke because I ruined it effectively. I need to order a new one. I need to swap in an old one. I need to use a different printer. All this kind of stuff. Fails come in and yeah, shit happens. You just gotta kind of work to it. And then additional, usually a 50% profit margin is also added in as well. And that'll give you a minimum sales price. Now that 50%, that is going to be completely dependent on you, the individual. This is kind of where you can factor in what is this worth to your client. And you can also kind of base it off of the individual cost price. So some clients, they don't really care about the total. They're just wanting to know the individual. So we have some clients that are like, yeah, if you can get me this for between 90 cents and 95 cents per part, that would be fantastic. And you kind of work that into calculations. You go, okay, well, with that, I can then, that's dictating my profit margin. I can then make 50% or 100% or 200%. These are 3D printers. They have a totally flat cost per unit value. So if you have all of these prices going into it, it can be a fantastic deal for both you and the client based on the speed, based on the cost. So it can really be, I'll scratch your batch. I'll scratch your back. You scratch mine per batch.
An unintended pun. My favorite type.
That's the best.
I'll
so
scratch your
effectively,
batch, you scratch mine.
Yeah. So after all of that stuff, it will give you a minimum price, and then you can tell them that. And then afterwards, after all of it printing, and after you time yourself, the prep, the post, the CAD, the slicing, all that stuff, you can then give them a final price. That is the totally standard process. Not just among 3D printing, but across any bespoke work. And guess what? If they say, hey, I need this by like in 2 days, that is totally an expected price increase on their side. They're kind of recognizing, yeah, this is going to cost a little bit more. I think just modern day people, we expect like, yeah, shipping doesn't take too long as far as the materials coming into it. But yeah, you printing it and checking it and doing all this extra stuff for a rush job, that costs more.
Yeah, and I think charging for your time appropriately is a huge deal. So going into some of these deals and saying, I like you said earlier, I estimate it's going to take me an hour, but it may take me 2 to 4. So going in, setting the expectations with the client to say it could cost you this much or even more if things come up and it's out of the range. Like, how do you want to handle this variability is something important. I think variability is totally okay. And it's also okay if the client's like, no, thank you. I'll go to somebody else who just gives me one-off pricing. They're likely going to get one-off pricing for something that may or may not come back correctly, that could be quite a bit more expensive. All these kinds of things are going into it. And that's probably a client that you don't want. If you have somebody in there saying that's already above what I was willing to pay, don't be too hungry for business. Don't go in there saying, okay, well then let me drop my prices and make it as cheaply as possible because I'm going to get a client that's magically going to pay me more money. It's not going to happen. That client is never going to pay you more money. They're always going to be cheap, and they're always going to be expecting more. And now you're wasting all of your time with a couple of inexpensive, low value, difficult to work with clients. So be careful when pricing these things. Charge appropriately for your time. And appropriately means I wouldn't start under $40 an hour for your time.
Oh yeah, no.
And we charge
Especially if you
quite a bit
have
more
CAD
than that.
skills to back it up. If you go, hey, this file is gonna, if I wasn't a CAD person, I was just a 3D printing person, and hey, you gave me this file and I can identify some areas that need some work. For example, we have a client who has a bunch of designs that they then emboss into their projects. And you go, hey, that's embossed like 5 millimeters. This is going to be needing an obscene amount of support material to uphold this design. And then you can go in and say, hey, I can pull in this file and I can reduce that embossing back significantly. You get the exact same design, but you have no supports necessary for it. I've just saved you a huge amount of post-processing time, huge amount of material, huge amount of print time as well, which all goes into the price. And it's going to be a better quality because it's not going to have any scars on it from the support material or the interlace. It's just going to be better and better and better. And you need to charge for that. CAD skills. It's a job.
Yep.
It's literally a job. So
you I totally agree with you.
Charge effectively. Yeah.
Yeah. I will say
thing that's go on.
I was gonna say I will say that there's I wouldn't say my default response was almost always no, actually, to clients. Because especially if you got somebody who said, I want these 3 widgets that are super tiny, easy to make, inexpensive. And you're like, oh, okay, well, I still have to factor in all of my time. So this is going to cost you $100. And they're like, $100 for these 3 little things that take it's like 10 cents a filament and 4 minutes to print. Like, right. So you get this client that comes to you with some tiny little project that seems not reproducible. And they want it for $5 because it seems like it should cost $5. And these are the worst clients.
It would cost us $5 to print it. Yeah.
Yeah, but not even, right? Because we'd be factoring in our own time, like yes, in materials and yes, in electricity and depreciation and all the other things. If
we're printing a part for ourselves, it's nothing.
But just be careful. It's an easy world where people are. I don't think they're usually intentionally trying to take advantage of you, although sometimes they are. They're usually not intentionally trying to take advantage of you. They just don't know what they don't know. And so I've had a lot of conversations with folks where I say, you can actually probably find that part online. I recommend you do that. It's going to be much more expensive if we have to do it. Now, if you're prepping for like a 10,000 part run, those are the kinds of clients that you're really, that's what you really want, right?
Yeah.
So you want those big runs where there's a lot of possibility for a larger thing down the line. But, those can be a little bit of a trap as well, where they're like, well, can you just do the initial work for free? Right? How about you just show me an example? So pitfalls, beware. Ultimately, those are some of the reasons I think we decided to roll our 3D printing operation back, is that we had difficulty sorting out the good clients and finding reproducible business. And these are some of the reasons.
Yeah. The other side of it, which is really funky, is that there's basically no logical correlation between the price of the product and the quality of the output. It seems insane, but you saying I'm going to charge the least and I've got a really good quality 3D printer and I can produce a good part, that means nothing. If someone then comes in and goes, hey, I've got a really expensive 3D printer, therefore I can charge even more, and I've got a printer that can be even more high quality and it can print really exotic materials, therefore I'm going to charge more, which makes all the logical sense in the world, means nothing when it comes to pricing. It is completely illogical, but we have worked with so many people that have come to us for product development work, for professional CAD work, where they say, hey, this is my prototype. And we have, good God, I've talked to maybe half a dozen people in person, not even online, in person, that have given me their part that says, hey, I worked with an engineering company, an engineering firm, and they charged me, I think, for the chap with the protein powder chap, who had a new invention for protein powder. And he had a little product that interfaced with this, with a pre-existing product. And he said, yeah, it's effectively, it's about that much of plastic. It's tiny. And he said, yeah, they charged me $8,000 for this. and I was gobsmacked. And he was like, and I picked it up, and it was garbage. It was PETG. The layer lines were revolting. They had actually taken it. There was scuff all over it, and they had proceeded to hand sand it. So it's like you could see the more pushed out layers had been sanded, and there was actually sandpaper grit inside this yellowed clear PETG. It was a vile print. I would feel embarrassed if I gave this to a client and then they charged $8,000 for it. I was like, that's smarmy. That's disgusting. How dare you do that? And then we've also had, and back in the old days, well before it was regulated, there's a few different websites where you could go on and say, "Hey, I've got a 3D printer. I can,
Oh yeah,
I'm local."
yeah.
Yep. Won't name any names, but lots and lots of companies did that, and people that had just Ender 3s could say, yeah, I'll print it for you. And they would charge obscene amounts for a quality that didn't deserve it.
Totally.
But now there's way more companies where it's way more regulated, and all the prints that you get from them are higher cost, but they are absolutely a good standard. But a lot of them, they won't even fuss around with basic materials. PETG, PETG, ASA. Nah, it's not worth their time. And so that's where you can kind of come in and film the gaps. But there you go. That's how you print out a part.
All right, Jake. Shall we transition to some CAD stuff?
Yes.
Let's transition to some CAD stuff. So, big announcement. So we have had, over the years that we've built this community, and we've gotten lots of emails and messages, direct messages, and obviously messages in Discord. So we have historically every year we do a revision of our large book. And the last time we actually removed some sections, we added some sections, and we had some kind of brand new projects in there. And this time we've been discussing what it is that we'd like to do with the big book. And we've come to the conclusion that this year we will not be doing a major revision of the big book, although we will still continue to do the minor revisions. And instead, we are going to write a second add-on continued project book, and we're gonna do it based on the requests that we've had from you all. So that we have 5 topic areas that we're going to be building projects for and writing a smaller continuation book for. 5 areas, 2 projects each, just in the same format as this book here. And Jake, do you want to talk about what those areas are?
Yeah, so we're still going to be making all of the changes and updates and upgrades to the Mastering Autodesk Fusion book. Obviously, we're going to be always releasing that book online for free. So if you've bought previous versions, this will always be available to you. We're potentially going to be changing out some of the projects within the book, but keeping all of the chapters and the topics the same. We're thinking about merging a couple chapters and then adding in some new projects and some new topics. But basically, there's so many topics, workspaces, but also really big umbrella terms that we want to talk about that we literally can't fit into the Mastering Autodesk Fusion book. We could do, then we'd have to compensate the price, but then you also just have like this massive book that's which is just it's no fun. The price becomes like ridiculous, and it's no fun. We have so much more stuff that we want to explore and teach you guys, and it doesn't really fit in that book anymore. So, as Josh said, we're going to be doing a Mastering Autodesk Fusion 10 more edition, part 2, whatever you want to call it, an extension of this book, where it's kind of with the mindset of you've worked through the majority or all of the Mastering Autodesk Fusion book, and you want to learn even more about the workspaces. So we're going to be touching on much more depth, much more functionality, with the mindset that you already have a fantastic base of knowledge about this. So we're going to be touching into a few different areas. But we're also going to be working with some companies, hopefully, not to sponsor, but to effectively showcase as real-world applications. For example, we get a lot of requests every single day, people emailing us, and one of them that comes up practically every single day, I think, or at least multiple times a week, is people wanting to learn more about 3D scanning It's an area that we've both Josh and I have got professional experience in. It's an area that I don't know a tremendous amount, and I'm learning more and more about the application every single day. And I kind of feel it in my belly, where it's just kind of warm me up. I'm getting more and more giddy about it every single day. And one of the topics that we've been approached for quite a few times, crazy amounts, is people wanting to develop prosthetics that they can 3D print. Where if you're working with either a human or an animal who has, very sadly, a limb that's lost, you can 3D scan it with either your smartphone, a relatively inexpensive 3D scanner, or even a very expensive 3D scanner that can cost usually up to like 30 grand or even more. And being able to take that three-dimensional bit cloud or a point cloud, surface effectively, pull it into a CAD modeling software, being able to build off of it, 3D print it very, very inexpensively, and change a human's or an animal's life it's insane for a very inexpensive cost. There's quite a few companies that we're planning on reaching out to basically say, hey, what is your workload? How can we make this as efficient as possible? It's something that we're really, really excited about. It's something that I've been thinking about for years. And we're now going to go into it. We're also going to be going into sheet metal. Finally, people have been screaming at us for years to try and implement it. So I will totally be going into that. We're teaching you guys as many things about the sheet metal workspace as possible. We're also going to be going into 3D forms, actually the sculpting part of CAD modeling, kind of where Blender and clay sculpting meets rigid dimensional engineering CAD softwares. Teaching you guys about, hopefully, the forms tool, T-spline surface modeling. This is all within a breed of organic 3D modeling. And where that meets dimensional parametric modeling is really interesting. And we've been wanting to teach about it for a long time. We're also going to be talking about AI and how that applies to CAD modeling. We've kind of reached this really nice peak of it where the public of the CAD modeling world are kind of recognizing, hey, people typing long paragraphs about what they want in their CAD model, and then this software doing it, it's actually almost comparable workload-wise as just you modeling it. And so this kind of text to 3D model, it's reached interest, and then people finally like, yeah, no, it doesn't really work. Really sorry. But the AI small tools that assist you into your workload is becoming more and more integrated and more useful tremendously. And that's an aspect that we absolutely want to go into and teach you guys as much as possible. How you can use external tools that flow into your CAD structure, whether that be for your 2D sketches, which Autodesk is doing massive work into integration, but also 3D modeling, but also imports as well. That's going to be absolutely essential to the future of CAD modeling. So super duper excited for that.
Jake, I just realized live on air what one of the precursors to when we say AI, one of the AI topics will be generative design. Now, this is a little bit different because generative is only available using cloud credits, right? So this might be us wading into territory where we're like, hey, if you've only got the free version of this, unfortunately, this section is paid. So that might be like one. We try to avoid those paid sections, but that
may be
an
additional bonus.
But what I'm realizing, because a lot of these models that you make with the generative design, you can specify the manufacturing technology that you'd like to use, and then the stresses and strains and loads, and you can add in the load calculator and a safety factor. And out the other end pops a model that should theoretically, obviously, you're gonna have to test it as an engineer, but it should match the requirements that you have. So what I just realized live on air is we actually need to do FEA analysis as well. So there may be some reason to do actually 6 new topics, and the FEA analysis topic will lead into the generative design workspace.
For anyone who doesn't know, FEA stands for finite element analysis. If you read our C's for CAD book, then you know all about it. It is effectively finite element analysis is looking at the mesh of a 3D model and noting all of the finite points that makes up all of the polygons of a 3D model. It's not like just some surface with an infinite amount of points. It's a locked down scale of complexity of calculations. And you're able to essentially say, hey, this part of my model is holding still, and I'm applying a finite force to this aspect. What is the bending? What is the shear? What is all of the engineering, mechanical kinematics that's going on inside this model as it's physically being pushed, and how all those forces are deforming the material of the product. This is a part where we're actually been doing some real engineering calculations, which I'm kind of excited for.
Yeah, I know.
I
I figured,
textbooks.
I was just thinking in my head, I'm like, are we missing something? I mean, we sure are. You know, FEA analysis is a powerful tool in Fusion. So if you guys are looking to level up and be engineers for real, that's a tool you'll use.
Yeah,
And
absolutely.
even if you're not, I mean, even if you're trying to create stronger 3D printed parts, this is still a tool that you can use. So yeah, so FEA analysis, that might mean 12 projects. That's almost half the size of the big book.
Oh my God.
Oh my
Just
goodness.
I'm just seeing the amount of extra work left.
Well, one of the things, and I guess as we're on the topic here, in the community. So now that you have some idea of some of the topics that we're going to be exploring, if you've got project ideas, things that you'd like to be able to do, please do reach out. We'd love to maybe even collaborate with some of you. So if you come up with a project and you want to write some of those project steps and take some screenshots and pitch it as a possibility of being in the next book as an actual featured project, let us know. We'd love to incorporate your thinking into some of this. And I think the way we generally structure this is the first project is meant to introduce the new workspace. So it's a simpler project with just the most basic tools in there. And then the second project is designed to build on those ideas and dig into some of the menus and get to know some of the deeper stuff. So that's the general flow. If you want to be involved, you want to mention in our next CAD book, then you should feel free to develop some stuff.
The other thing that I wanted to chat about before we run out of time is build plates, because I have been literally pulling my hair out this entire week. Last week I was saying about just how many failed prints I had back to back to back. And we just had a slew of people saying, oh, this could be wrong. Try that, change this setting, yada, 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 which is lovely. I love it. And I tried out every single one of them. And it basically just comes down to me, Jake, being dumb and actually ruining my build plate. Really quick, bizarrely enough, before Josh and I went on our leave of absence, I was printing on the stock build plate for months and months and months, and it was fantastic. Oh my God, it's lovely, beautiful. What amazing prints. And then we came back from the trip, and every single print I was doing was failing. I'm like, what's going on? I haven't done anything. It's enclosed. It's not like dust is getting everywhere. I've cleaned it 1,000 times. What is going on? I know these build plates are consumables. Trust me, we've bought enough of them, but it was just failing over and over and over again. We're like, what the hell is going on? Basically, after doing lots of research and doing tests out the wazoo of all of my different printer settings, slowing down, warping, brims, blah, 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 everything, it comes down to the fact that the people who have been manufacturing build plates have changed the recipe. Back in the day, I'm talking like 5, 6, 7 years now, when PEI sheets first came out, it was a revolution. It seriously was, because we'd been printing on blue tape and glue sticks. This is like back in the day when ABS was still a common material. For those of you that are kind of in the newer space of 3D printing, one of the tricks to printing with ABS without getting warping was to literally dissolve some ABS material in acetone. So it like basically become like a slurry, and then painting it on your build plate, hitting it with a hairdryer so all the acetone would evaporate, and it would leave you with this incredibly thin atomic layer of ABS that was kind of bonded to your build plate, and then you can print on top of it. And then when you peeled it off, the bottom surface was kind of crumbly, but it totally worked. And you'd have to go through like literal chemistry to be able to print with this stuff. And then PEI came out, and it was a bit of a revolution. We printed a ton of stuff on it. It's like, hey, when it cools down, it pops off. Oh, amazing. And for a long time, it was like, oh, but it is a fingerprint magnet, so clean it with alcohol, clean it with soapy water, and you'll be fine. He's like, yeah, we've all been doing that on our glass build plates for years, so no problem. And then I don't know when, but the manufacturers have now been adding additional adhesive layers onto it, which makes build plates much easier to stick onto, with the tiny little fine print at the very bottom, do not clean with alcohol because it denatures the organic surface and removes that adhesive. So I have been effectively dissolving the top layer of all of my PEI build sheets with like 99% alcohol for ages, and it's finally withered away. So then you guys gave a ton of fantastic suggestions last week. Oh, you should get this, you should get that. So I've looked into it, and I've Printed by John suggested, oh yeah, you should get Bamboo's Super Tack, cool Super Tack. So I ordered a couple of them, and they're coming literally today in like a couple hours. And I have seen in the chatter of the 3D printing community, Bamboo's build plates have been going through a bit of a quality control problem, and people are saying it's now hit or miss whether or not it will actually work. So they go, if you have ordered this quick tack, I think so, fast tack, whatever it's called, build plate in December, you are good to go. What an amazing build plate. It works fantastically. Their pre-built settings are phenomenal. Awesome. If you've ordered it after December, just return it, because the chances of it working as advertised is like roll the dice. Great. Awesome. So I haven't actually printed on this build plate. I don't even have it yet. But I will I'll let you guys know. But yeah, officially now alcohol is that's now out. Unfortunately, I've got gallons of alcohol that I used to use when I was doing SLA prints that is now just kind of chilling in my workshop. So not great. But yeah, I'll be so if you guys have any other suggestions of any of the build plates to use, please let me know and I will absolutely check it out. Still looking for a very good build plate that I don't ruin in the future. So yeah, there you go. That's all I got, man.
You ruined it.
Damn.
All right. Well, we will show off the I Made a Thing. I think next week we did see I saw a couple come in there. Grandpa Makes just shared. I'll just say out loud that he made a dashboard and fence to support a router table and 3D printed it. Total cost was about $4, and it had a dust collection port on the back of it. So relevant to today's conversation.
But we want to show those off next week.
So we'll talk next week about some of these. We talked last week about the text tool and some of the text commands. We will dive deeply into that tool next week. There is some additional really interesting stuff we can do with it. And maybe, Jake, just maybe we'll get back to what the people like, which is some challenges. So we'll get some of those challenges flowing for you again.
Yes.
And last little announcement here is that we will have Too Tall Toby on the podcast in March. So we will be talking. We have done one of his challenge models.
We've done a lot of his. We've done a lot of them.
There you go. So we've done a handful of Too Tall Toby's challenge models. I had a really nice conversation with him about doing some print in place models. So little practice models that have print in place mechanisms, if possible, and also multi-part fun builds. So having like 3 to 5 basically consecutive projects that lead to something you can 3D print that's actually fun. So dun dun dun, coming down the line. And we will talk a little bit too on that pod, and we'll tease it more when the week before, but we will talk. Will we continue the bicycle challenge? Yeah, we probably will continue the bicycle challenge, but I think I'm realizing we need to make sure it's not crazy. It's tough to break apart into the chunks that are not so hard. But what we will one of the things we'll do with Too Tall Toby is we'll talk a little bit about his design process versus ours, and his will be using either Onshape or SolidWorks, or maybe both, and ours will be using Fusion. And we'll talk about some of the pros and cons and differences of these software. So maybe that'll be useful for you all. And that's it. That's all I got. That's awesome, the pod. Guys. All right. This has been the
Fantastic.
CADclass podcast. Once again, I'm Josh.
I'm Jake.
And we will see you next week.
See you guys.
Cheers.